N+1 stage, they had to go back. He's written a lot about that in his autobiography. The last...
Hope was at a premium on the other side of the Atlantic as well. Desperate to build awareness among Americans about the fact that millions of people were dying of HIV/AIDS, even though there were drugs which could save them, intellectual property activist James Love found few people in Washington willing to so much as discuss the issue, and was surprised by the response of some he thought would join him.
A lot of American AIDS activists were opposed to this. They didn't really care. They felt like they had drugs. If they had cheap drugs in Africa, they thought it might discourage R&D for them. They had insurance. They didn't see the pricing problem.
Many in the West feared that treating people in the Third World could cause the AIDS virus to mutate and become resistant to the drugs.
The rap was you couldn't give drugs to people in Africa because they would misuse them. They wouldn't be compliant in terms of treatment. They'd develop resistance. Resistance would come back and kill Americans or kill Europeans.
They are mostly illiterates, can't read the information in the leaflets and the drugs packets, and have to cope without a healthcare system that can tell them about the disease they have.
The biggest problem for antiretrovirals, this sounds small, and some people, if you've traveled to rural Africa, you know this. This is not a criticism, just a different world. People do not know what watches and clocks are. They do not use Western means for telling the time. They use the sun.
How the first world thinks of us, or of the third world. They are not willing to allow their research, or especially the pharmaceutical sector, to come into our country, fearing one, that we'll misuse them. We hear that German over there, the GSK head of research and development, he says they don't know how to read the label, they'll misuse the medicine. And the first world is afraid that because of misuse of medicine, there'll be resistance developing. Now, as scientists, you all know you don't develop resistance to the particular molecule. The resistance comes because there is a resistant strain of bacteria which develops. So it's not resistance to the molecule. So that's head of business development and medical development of a first world company talking like that. And USAID, which is one of the biggest suppliers, which should have supported, their head saying that it's a different world. They'll use the sun to detect time, so they'll not be able to take medicines. So I end my presentation here. I know I've taken off it into a particular direction, but as Indians, we need to understand that the patent regime, as far as pharmaceuticals is concerned, is very restrictive. It may be true in other terms. I'm not saying that it should harm innovation, but patent regimes and intellectual property rights cannot come in the way of saving human lives. That as a government health worker, that is one of my primary requirements, and as scientists I do understand we can have other alternatives, but patents cannot be restrictive of public health. Thank you and good afternoon.
I thank the organizers for inviting me to make this presentation. Am I audible? I'm from RIS. RIS is a policy think tank for Ministry of External Affairs. We also do a lot of work with the DST and other government departments on science, technology, innovation. You can go to our website ris.org.in to find out more about our work. Basically, in this presentation, on account of lack of time, I would not go into details of what I'm going to explain. So you can just, next. IPR, actually, you should think of IPR as a strategic asset because it can be used in technology transfer. But then the point is that you should think about IPR much more than technology transfer. Because, the scope and the breadth of the IPR owned is important to use it as a strategic asset. Which means that companies may file many patents related to one innovation technology, which often result in a patent ticket. So a patent ticket would cover a technology, but which means that the company will be able to hold many patents around the technology so that others may not be able to use it, or even if someone wants to acquire a technology, they have to buy from that company only. This makes inventing around very difficult and enables to negotiate better deals in technology transfer. This is important for public sector because if you have very few patents and if you don't have patent tickets, others may be able to invent around your idea and then still get on with their work without even bothering to issue a patent. So laboratories should stop with filing few patents, but think in terms of building patent portfolios. This is important. You should think in terms of patent portfolios covering technologies than just few patents, and then should file more patents related to invention, including process and product patents. So if you have a product, think about the equivalent process patents, because sometimes, when you sell a technology as a bundle, the industry might prefer to get both the product as well as the process patent from you than going to one organization for a product, then to another one for process. On the other hand, the cost of filing and maintaining these assets should also be looked into, because you can keep on filing patents and getting patents, but then you have to maintain them. You have to ensure that every year you pay the proper fee, and then somebody will have to monitor that whether they are being infringed or they are being put to unauthorized use. So it is a task which demands a lot of attention and money. So best thing is that you don't take upon yourself doing all this stuff. Give it to a professional agency which you can handle it much better way for you. Next one. So as a laboratory or as an R&D center or as a university, you should think about linking IPR policy with business strategy. For laboratories that are heavily into applied research or R&D, IPR policy should be part of the business strategy, because IPRs can be used for many purposes. Patenting can be for defensive purposes, so that even if the technology is not commercialized, nobody else is able to copy it or infringe it. This is important, because you may not be very keen to commercialize it, you may not see much value in it, but then somebody else may just use it without your knowledge or permission just because you have not patented it. So as a defensive strategy, you should try to ensure that whether you are going to commercialize or not, go for IP first. Acquire IP first, then think about commercialization, utilization later on. Patenting should be from the early stage of invention till the R&D results in tangible outcome. Why this is important is because, even in the early stages, you would get an idea that if you have a patent, others may not be able to copy it, others may not be able to use your idea or misappropriate idea. On the other hand, if you forget to patent, or if you by sheer negligence don't apply for patent, but then you talk about the idea elsewhere or it is published, others may simply use it without you even knowing it. So while ideas per se cannot be patented, new novel processes, techniques and inventions that have utility can be patented. So keep that in mind whenever you think of an R&D project as to what could be new novelty things that could be of some use, that could be patented or not. So it is better to have a strong IP portfolio related to the core activity of the R&D center. Whether you were a specialist in a process or related to new novel compounding, or you work in a specialized area in chemistry or whatever may be your field, build up a core strong IP portfolio in your core competent area. Then link IPR policy with the strategy is important. It should be considered as not just from the revenue angle. It should be thought in terms of the broad mission, objective and business policy of the R&D center. One question which scientists should be really aware of when they think about patenting is that what should they do if they come up with something new? Should they publish first and then go for patenting later, or should they wait that the patent application is filed first and published later? Ideally speaking, if you have something novel which you find something very important, but you know that it could be some good commercial value, don't publish it first, or at least don't reveal the key idea first. Instead, you think about what could be the potential for patenting, think with an IP lawyer, stating that also look at the prior art. You have made a clear contribution to the state of the art, and your invention is going to be something that is not anticipated or found in the prior art, then don't publish it in the first place. Don't make public presentations, don't make conference presentations or even journal articles, but go for a file for an IP first and then go for the publication or presentation later. Now the dilemma here is that, should I not tell anything to the public? No, it is not like that. You can reveal certain things, but the key component or the key idea should not be revealed. For example, you have a novel compound or a new composition. Don't reveal the exact composition or the process of that. it could be given a coded name, and you can say that we have discovered or we have invented a novel compound to attack this disease or to come out to surmount this problem. Stop with that level, and then file for an IPR, and then think about disclosing in public. Publishing after applying for a patent is fine, but again CAT should be ensured that disclosing information till the patent is granted, because even after that there could be opposition. Because once the patent application is filed in India, opposition can happen in two stages. One, pre-grant. Even at the pre-grant level, somebody can go through a patent application and then oppose it that it is not novel, it is covered by prior art, there is no utility, or there is no productive innovative step in that. So you should be very clear-cut as to what exactly you are disclosing in your patent application. And then the second thing is that even after the patent is granted, post-grant opposition is possible. Particularly in pharmaceutical, chemical industries, post-grant opposition, pre-grant opposition are very vital, because no competitor is going to allow any patent to go unchecked if it's got great commercial value. So when you go for that public disclosure or patenting or making it as a publication, think about these things first. This is important for technology transfer and commercialization, as a technology is covered by many patents, and if a key patent application is rejected, then the value of the invention will be affected. For example, you have about 10 patents, but of the 10 patents, you have one patent that has got a key process patent. If that is challenged and then questioned, and then if it is proven that it is not of something of the patentable quality, or it doesn't have the novelty, then it could be the patent could not be granted, or if granted, it will be withdrawn. In which case, the value of the other patent which you own will come down. So you should think about this aspect also when you go for patenting. Next. So research centers should have clear-cut policies on IP and publication disclosure. In many companies, key novel compounds or encoded information is kept secret. Not even all in the R&D center will know about it. So it will be a good practice to vet information disclosed in publications and in presentations in preparation to ensure that IP claims are not affected. IP team and R&D team should interact continuously, and the potential for IP should be identified in the early stages itself, and if necessary filed first. This is important for IP protection for new compounds and for early leads in drug discovery. I think Dr. Padma Puja would cover some of these aspects, because in pharma it is very important. An organization give importance to patent IPR. Also, scientists should think that only publications matter to recognition. So these days, not just publications, even patents also matter. So keep that in mind when you think about IPR. Next. IPR, number, quality and value. The dilemma here is that should I patent what all is possible and what all is feasible, or what all I can afford, or should I look for quality or not the numbers? Fundamentally, the problem is that, often you can have 500 patents, 200 patents just to show up the numbers. But they may not have much commercial value, or you will be spending more in maintaining them and then paying for them than getting any licensing royalty from them. So you should be able to take a very objective view of the inventions and then see whether the potential is there to license or to commercialize it, and then go for patenting. This is important because this should be done more on an objective basis than on the basis of, okay, I want to show this many patents filed this year from my center, file 100 patents like that. On the other hand, valuation of IP is very difficult, because in technology, what you may anticipate today or what you may not anticipate today may be very important. Your technology may become obsolete in 6 months or 1 year. Another novel process or new product may come up, and then your invention may be valid, but then nobody takers would be there. So you should know how to value the intangible asset of the IP, and then accordingly think about patenting, think about licensing. Next. Licensing, I would not go into detail because it will be covered by Dr. Padmaja, and then it has been covered earlier. Basically, broadly speaking, there are two opportunities of licensing. One is exclusive and non-exclusive. While licensing is technologies protected by IPR or non-exclusive basis may appear to be an attractive option. But then the problem is that when you go for a non-exclusive licensing, many people will be applying for will apply for commercialization. So number of licenses may be more, but then the income may not be high because often big companies or single entity may be willing to pay you more on account of exclusive licensing because it gives them strategic advantage. Non-exclusive licensing may be there to prevent monopoly control or over a product or use of that invention in commercialization. It all depends upon the importance of the technology, availability of the alternate technologies and commercial value of technology. For example, even if you think that exclusive licensing is not good for the society, I think at this stage the R&D center or the lab alone cannot decide on that. There is a public policy angle to that, so they should think in that angle as well, and then say that okay, they should discuss with the ministry, should we go for exclusive licensing for this important invention, or is the government willing to show us some other options? So licensing strategy should be developed and the option should be explored before entering into any decision. The terms of licensing may include reach-through licenses, royalty, restrictions on use of technology. Reach-through licenses are very common in many technologies because, if you have a very key component technology, you want to negotiate terms and then say that this is fine, you use this technology, but if you are going to use this technology for developing something else, I would need royalty for that as well. Again, royalty can be on the basis of revenue or lump sum or combination of these things. However, if the period for which the royalties to be paid is less than the life of the patent, then it may amount that too much, you may not expect no royalty at all in some years. Hence, it is better to maximize royalty when the patent term is valid and as technology may become obsolete or substitute may be developed or commercial value may decline. A licensing agreement should be done in such a way that commercial gain is maximized, which means that you need to think of a trade-off. Whether you go for a 10-year royalty, which is regular, but then it is definitely there, or a short or 5-year royalty, which is maximum in the sense that you would get good amount, but then the period is short. So these things you need to evaluate upon the nature of the technology, available substitutes, and then the market for the technology. Next. Fundamentally, licensing of the patent does not exhaust the options of the use of the patent of the own use. So you can use the technology for your own use. At the same time, licensing term should be drafted and negotiated carefully. Non-disclosure agreement is important because sometimes, if you have a very key technology or something which is very vital importance, the person who licenses it should ensure that he is not disclosing it to someone else. And then sharing of technology again could become problematic area because people often share technology without the permission. So your licensing terms should be very crystal clear on that what do you want to permit, and you should not permit others to share the technology without your permission. Then cross-licensing is another option. What happens is that you have some technology, others have some other technology. So you can enter into a deal that you would license your technology with them in some way, they would license it to you. So these are typical commercial terms where you look at it, the value of your technology and the technology of the other. Normally what happens is that no company or no R&D center will have all the requisite technologies to commercialize a product, which means that people who want technology would go to different centers, assess the value of the technology, their importance, and then look at the best option available to them. Which means that if you have a very strong IP portfolio which covers many aspects of the technology, the demand for the technology may be higher than what others are able to offer to them. So when the processes are important, substitutes are available or they develop, then licensing of a product can provide more commercial benefit if the product has got no substitute. In pharmaceutical, agrochemical and other industries where the core of the invention and technology is also the single compound or molecule, product data IPRs matter most. It could be a compound or a modified gene or a modified protein. Next. I think this I would skip because this is nothing. But the key question here is that licensing and public welfare. Often we are told that traditional licensing is the only available option, but it is not so because there are other options like humanitarian licensing and then licensing based on differentiation in markets, licensing agreement to share technology, etc. Fundamentally, if you look at it, in the AIDS crisis and the access to medicine debate, resulted in a lot of debates about licensing, particularly with the universities in USA. The question arose repeatedly as public institutions, should they maximize their licensing or should they maximize public welfare? So it forced a rethink on the university technology managers, so they came up with many options of licensing. For example, humanitarian licensing means that you would give a licensing for use of the technology for humanitarian purpose on concession terms than on commercial terms. Like that, different universities have different policies. UC Davis has got a fantastic policy for sharing technology. UC Berkeley has got a different policy for sharing technology, where in some areas they want to promote technology and technology transfer than maximizing the revenue. So if you really have the time, if you really have the patience to go through some of these things, please go through the licensing options such as humanitarian licensing, and then work of organizations like PIPRA, which are engaged in transfer of agricultural technologies to developing countries on a nominal licensing amount, and at the same time they also ensure that you get access to better technology. So technology diffusion is critically important in developing countries, and public interest is equally important. So organizations like PIPRA are helping universities to draft and choose such licenses. So if a research center prefers public welfare over commercialization, it should first get IPR, at least for defensive purposes, and then put that to best use through such licensing, including transfer of technology. Next. I would take few minutes to explain the case of BT cotton in India and China. Why this is important is that BT cotton is an important crop in both India and China. And in case of China, what happened is that Chinese